In the second book of Euclid's Elements, we get into rectangles. And the reason we get into rectangles is so we can explore the field of quadratics. Now in algebra, or rather algebraic terms, a quadratic function is one that is defined by ax squared plus bx plus c. To see how we approach these types of problems in Euclid's Elements, consider this square. We will label the sides of this square as x. And consider this smaller square. We will label the sides of this smaller square as a. And we'll also have these other two rectangles to fill in the blanks. Now note that the area of this entire rectangle is a plus x squared, which is equal to the area of the bigger square, x squared, plus the area of the smaller squared, a squared, plus both of the areas of these smaller rectangles, which we know to be equal. So that gives us 2ax. We thus have the quadratic x squared plus 2ax plus a squared. Euclid's Elements starts off with two definitions followed by a set of propositions. The first definition is that any rectangular parallelogram is said to be contained by the two straight lines containing the right angle. So, given rectangle ABCD, we say that line AB and AC contain the rectangle. The second definition, and in any parallelogramic area, let any one whatever of the parallelograms about its diameter with the two complements be called a nomen. So if we have a setup as we had previously, where we have the bigger square, the smaller square, and the two complements, then we can define the nomen to be these three areas. Now a nomen is a carpenter's square. It's the L-shaped tool that's used to get right angles really nicely. Notice that these three areas look like an L, so it looks like a carpenter's square, so we call it a nomen. The climax of the second book of Euclid's Elements is a proposition that shows how to construct a square that is equal in area to any rectilineal figure. This particular process is called the quadrature of the rectilineal area. The idea being that we can measure the area of any rectilineal area by performing the quadrature of it or converting it to a square, and thereby we can measure the area of the square and know the area of the rectilineal figure.